factors control the physical, chemical, and biological properties of soil and ultimately determine soil fertility and productivity. So let us start with the historical development of the concept of soil forming factors. 1. Historical contributions in soil formation. The scientific understanding of soil formation started in the early 20th century. Contribution of Vasily V. Dokuchaev, 1900. In 1900, the Russian soil scientist V. Dokuchaev, WHOIS also known as the father of soil science, proposed the first concept of soil forming factors. He suggested that soil formation depends mainly on three major factors: climate, organisms or biosphere, parent material. This was the first scientific explanation that soil is influenced by environmental conditions rather than being simply weathered rock. Contribution of Hans Jenny, 1942. Later in 1942, soil scientist Hans Jenny expanded Dokuchaev's concept and proposed 5 soil-forming factors. These 5 factors are climate Cl, organisms or biosphere O or bio, relief or topography R, parent material P, time T. Hans Jenny expressed soil formation through a functional equation SFCLORPT, where S represents soil, Cl represents climate, O or bio represents organisms or biosphere, R represents relief or topography, P represents parent material, T represents time. This equation means that soil properties are controlled by the interaction of these 5 factors. 2. Classification of soil forming factors. In 1949, scientist Joff classified soil forming factors into 2 groups: active soil forming factors, passive soil forming factors. Active soil forming factors. Active factors provide the energy required for soil formation. There are 2 active factors: climate, living organisms, biosphere. These factors control chemical reactions and biological processes in soil. Passive soil forming factors. Passive factors provide the foundation or raw material for soil formation. There are 3 passive factors: relief, parent material, time. These factors determine the structure, depth, and development of soil over time. First, climate as a soil-forming factor. Climate is considered the most important factor in soil formation. It strongly influences weathering processes, organic matter decomposition, soil moisture conditions, chemical reactions in soil. Elements of climate. The important climatic elements affecting soil formation include rainfall, temperature, humidity, aridity, wind. These elements determine how quickly rocks weather and how soils develop. Soil forming processes influenced by climate. 1. Laterization. Laterization is a soil forming process that leads to the formation of laterite soil. Conditions required: high temperature, high rainfall, warm and humid climate. Regions where it occurs. In India, laterization is commonly observed in Tamil Nadu, Karnataka. Under these conditions, intense weathering removes many nutrients, leaving behind iron and aluminum oxides, which give laterite soil its reddish color. Though podzolization. Podzolization is another soil forming process. Climatic conditions. cool climate, high humidity, low temperature. In these conditions, organic acids leach minerals downward, leading to the formation of podzol soils. Such conditions are typically observed in cool and humid regions, including parts of northern India. Additional climate-driven soil processes. 1. Salinization. Salinization results in the formation of saline soils. Conditions: arid and semi-arid climates. High evaporation rate. Because evaporation is high, soluble salts accumulate in the upper soil layers, making the soil saline. Though formation of acid soils. Acid soils are commonly formed under humid climatic conditions with high rainfall. Process: heavy rainfall causes leaching, which removes basic cations such as calcium Ca, magnesium Mg, potassium K, sodium Na. When these basic elements are removed, the soil gradually becomes acidic. 2. Biosphere organisms. The biosphere is the second most important active factor in soil formation. It includes all living organisms present in the soil environment. Components of the biosphere. The biosphere includes vegetation, microorganisms, soil fauna, soil flora. These organisms play a critical role in soil development. Functions of soil organisms. Soil organisms help in decomposition of organic matter, formation of humus, nutrient cycling. Through these activities, organisms improve soil fertility and soil structure. Humification process. One of the key biological processes in soil formation is humification. Humification refers to the process where organic materials decompose and transform into humus. This process mainly occurs in the horizon of soil, which is the organic layer. Humus improves soil properties such as water holding capacity, nutrient availability, soil structure, organic matter decomposition. During decomposition of organic matter, many organic acids are produced. These organic acids help in weathering of minerals, release of nutrients into soil. Thus, biological activity indirectly contributes to soil mineral transformation and nutrient availability. Van Beem factor. An important concept related to soil organic matter is the Van Beem factor. This factor explains the relationship between organic matter and organic carbon in soil. According to the Van Beem concept, 100% organic matter contains about 58% organic carbon. Using this relationship, to convert organic carbon OC to organic matter OM OC 1.724. To convert organic matter to organic carbon OC OM 1.724. Here 1.724 is called the Van Beem factor. Third, relief or topography. Relief refers to the elevation and slope of the land surface. Topography strongly influences soil formation by affecting soil depth, soil erosion, drainage, soil color, nutrient accumulation. Effect of slope on soil formation. 1. Steep slopes. On steep slopes, soil erosion is high. Soil becomes shallow. Soil color becomes lighter. Nutrient levels are low. Though gentle slopes or lowlands. On gentle slopes, Erosion is minimal. Soil deposition occurs. Soil becomes deeper. Soil color becomes darker. Nutrient levels are higher. Thus, slow position greatly affects soil development. Catena concept. An important concept related to relief is the catena concept, introduced by Geoffrey Milne in 1935. Catena refers to a sequence of different soils that occur along a slope. In this case, climate, organisms, parent material, time remain the same. Only relief or slope position changes, which leads to the formation of different soils. Typical slope positions include hilltop, middle slope, lower slope or valley. Each position experiences different levels of erosion, deposition, water movement. Therefore, soils at different slope positions have different characteristics. Fourth, parent material. Parent material is the original rock or mineral material from which soil develops. It is considered a passive soil forming factor because it provides the raw material for soil formation. Types of parent rocks. Igneous rocks. Examples include granite, forms sandy soils, produces acidic soils. Basalt, forms black soils, rich in basic cations. High nutrient content. Types of parent material. Parent material can be divided into two main types. Residual parent material, sedentary. In this type, soil forms at the same place where the parent rock exists. There is no transportation of material. The soil develops directly from the weathering of underlying rock. Residual parent materials may be consolidated, unconsolidated, though transported parent material. In this case, parent material is transported from one location to another by natural agents before soil formation. Agents of transportation. Water. Deposited material is called alluvium, forming alluvial soils commonly found in river plains. These soils are usually highly productive and fertile. Gravity. Material transported by gravity is called colluvium, forming colluvial soils. Wind. Wind transported materials form sand deposits called aeolian soils. Silt deposits called loess soils. Loess soils are usually fertile and well structured. 5. Time as a soil forming factor. Time is another important passive factor in soil formation. Soil formation is an extremely slow process. On average, about 1 inch of soil formation requires approximately 800 to 1000 years. Since 1 inch equals about 2.54 centimeter. Therefore, approximately 2.5 centimeters of soil may take nearly 1000 years to form. Conclusion. To summarize today's lecture, soil formation is controlled by 5 major factors: climate, organisms, relief, parent material, time. Among these, climate and organisms are active factors, while relief, parent material, and time are passive factors. The interaction of these factors over long periods leads to the development of different soil types and soil characteristics. Understanding soil forming factors helps us better manage soil resources for sustainable agriculture and environmental conservation. Thank you for watching this lecture on Beyond Agriculture. In the next lecture, we will explore soil forming processes in more detail.